Today we are going to do our first lab of the year where we're going to be a pretty simple one. We're just going to try to find the velocity of a cart, a dynamics cart we call it, that's moving on a horizontal surface. In other words, it's going to represent constant velocity. We're going to find what that constant velocity, what that uniform motion is of this dynamics cart, this low friction car, dynamics cart moving on a horizontal track. Now, this is not going to be a full lab write-up. Sometimes you've got a problem, variables, hypothesis, all that jazz. This is only going to be certain components of the lab. We're not going to overwhelm you with everything all at once. We'll introduce things with each lab, introduce a few new things with each new lab. The first thing that you're going to need to do for this lab, besides the problem, and the problem is already given to you in the form of a question right here, what is the velocity of a low friction car moving on a horizontal track? The first thing you need to do besides that are the apparatus and materials. So you're going to list everything that you're using in this lab. Got it? Now, I'll tell you what you're using in this lab, okay? The first thing you're going to use is this low friction dynamics cart. One of these red or blue carts, doesn't really matter which one you're using. Pick whichever one happens to reach your hand first here. One of these low friction dynamics carts. You see here, if I spin a wheel here, keep spinning for a while, still spinning, still spinning. Because these are such low friction, the wheels keep spinning for quite a while. Now, that is a couple of implications here. One, when I give this a push on a nice horizontal surface, it should keep moving at more or less a constant velocity. It might slow down a little bit due to friction, but not very much. Now, the flip side of that is that because it's such low friction, any little bit of dust that gets in those wheels messes it up. So we want to make sure that we keep these carts off of the floor. There's going to be a track that you're going to use. There's the cart that you're going to use, and there's going to be a track that you're going to use. Some of them are metal tracks like this. Some of them are wooden tracks. Doesn't really matter which one you have. You want to make sure that you have your cart riding on a track. Now, this cart is what we call a smart cart. It's going to collect all kinds of data, all kinds of data. It's like the sensors they put in NHL jerseys now. You ever go to a Flames game, you see the scoreboard, it tells you exactly how many meters this player has skated for the game. And it's real-time updates because of the sensors that are in that player's jersey. It tells you ice time, it tells you all that stuff real-time, and that's based on the sensors that are in that hockey player's jersey. Well, there's sensors in this as well, in these carts as well, that measure all kinds of things. The position, the velocity on the x-axis, the velocity on the y-axis, on the z-axis, the acceleration, rotational motion, all kinds of stuff, most of which you don't even need or will never need in Physics 20, but it's there. There's two things that we're going to need to record from this data, time and position. That's it. But how do we get the time and position from these carts? We're going to connect it to our phones via Bluetooth. I had you download an app called SparkView. One person from each group is going to connect one cart to the SparkView app via Bluetooth, which is going to real-time stream position data, time data, acceleration data, rotational motion data, X, Y, Z axis, all kinds of stuff directly to your phone. Now remember, you're not going to use most of that, but it's going to stream all of that data to your phone. So what else we need? We need a cart. We need a track. What else we need? What's the third piece of apparatus or third material that we need? Your phone. It's not pictured here. You need a phone. Now, you're going to use a pencil. Maybe you use a pencil to write something down. We're not going to include that with materials, right? We're going to include the important things that we use here. Not like when we talk about going to a garage to have your car serviced, and we say, what are the materials that the mechanic used, that he or she used to change your oil? Well, maybe they used a paper towel to wipe off the oil cap when they spilled a little oil. We're not listing that as a material, right? We're not listing a pencil or an eraser or a piece of paper as a material. We're listing the things that are relevant to the lab itself. So that would be your cart, that would be your track, and that would be your phone with the SparkView. Does that make sense? All right. So there's the first thing that you're going to have to really do there. When we collect data, you're going to import it into a spreadsheet, and it's going to look like this. It's going to look crazy. Way more data than you're going to use. But it's going to look something like this. We're going to filter it down to something that looks like this. I'm going to explain to you how that's going to work, okay? But I'm not going to do that until after you've collected your data. I will tell you right now, just as a little heads up, when we create a data table, we always want to label our table. So in this case, it would be table 1, position of a car as a function of time, or something like that. It's something that just describes the data. We'll talk a little bit more detail about that as we actually go to do the analysis, how to sort through this data and turn it into this data. But what I want to do right now, with you, before we go over any of that, is show you actually how to collect the data. So I'm going to take a cart, and you're not going to see this on the podcast, but pretend you do. We're going to take a cart. We're going to put that cart on the floor. I've got it on the desk right now because I want you guys to be able to see it. We're going to put it on the floor, though, because A, the desk might not be level, and we want a level surface, right? And B, we don't want this cart to fall off of this track onto the floor. These are made out of plastic, but because of the sensors in them and because of the low friction wheels, these are about $300 each. We don't want to drop one and break it because we're being a little careless and put a cart up on top of the desk, okay? Can I get you to do me a favor? Just make sure your hand is there so it doesn't fall off, okay? Thank you. Now, I'm going to turn this cart on. There's a button on the side of it. You'll see the on button on the side of it, even if you can't see what I'm doing right now. Okay, I'm going to turn it on. There should be I'm going to turn this on its side so it doesn't roll off. There should be a red light that's flashing. Now, I'm going to connect my phone. I'm going to connect my phone via the SparkView app to this cart that I've just turned on. So you're going to go into the SparkView app, and you're going to see a menu that looks like this: sensor data, manual entry, sensor data, remote logging. I'm going to click on sensor data. And when I go to sensor data, we should find that that a little thing pops up on the left-hand side that has my cart, the number of my cart. They're all labeled a little bit differently. The number of this one is 364050. So I should see over on the left-hand side, on the board here right now, I have it connected already. You should see the opportunity to connect it, right? And then you're going to click on your cart and connect it. Once you do, it should look something like this. Although in this one, I have 2 of them connected. We only want to connect 1 of them. Connect yours. You're going to have 8 groups, 8 different carts. You're going to see a bunch of different options because everybody's going to have them turned on. Make sure you connect your cart and only your cart, your one cart. Good? Once I've got my device connected, then I want to go over to the middle column here. Okay, you're going to see all these different options. And it doesn't really matter which one you click in terms of collecting data. It's going to collect all of the data, regardless of which button you check. But it's going to be easier for you to see what you want to see if you check off the right box. Does that make sense? All the data will be there. So if you do happen to check off the wrong box here, it's not the end of the world. But it will be harder for you to see if you have good data if you don't check off the correct box. I want you, and you might want to make a note of this, I want you to check off this box, the position box. This is showing velocity because this was set up for a different lab, but I want you for this one to check off the position box. And in the far column, you're going to circle either graph or table and graph. Doesn't really matter there. Bottom line is we want to be able to see a graph. And that graph is going to be plotted real time. As the cart moves, we're going to see a real-time graph. So, first column, select your cart and only your cart. Second column, select position, the position. Make sure everything else is unchecked. Just position is checked. And then third column, click on that graph. First one or the second one. Now, when we go to collect our data, we're simply going to give this blue cart or red cart or whatever it happens to be a little bit of a push from the far end of the track towards the close end of the track. Make sure that somebody in your group is protecting either end of this so that it doesn't slide off and collect dirt in those wheels. Okay, we're going to have 3 or 4 people in each group, so it shouldn't be a big deal for somebody to put their foot at the end of it to keep it from sliding off. Got it? Give it a little bit of a push. When I say give it a little bit of a push, I don't mean send it flying at 20 meters per second. I don't mean push it halfway down the track. I mean, just give it a little bit of a push just like this. You want to put your hand there again? Thanks. Give it a little bit of a push just like this. Make sense? Now, this thing popped out. That doesn't matter if it pops out or in. Doesn't make any difference for you guys. It does for some labs that we do, but not for this one, okay? Now, when we give it a push, or I should say before we give it a push, I'm going to turn this off here. There we go. Before we give it a push, we want to make sure we press the start button so that we're actually recording data. That start button isn't on the card itself. This is within the app. So press the start button and then give it a push. You will find that there's a little bit of a time delay between the time you push the start button and the time that it will actually start collecting data. You'll see that. Okay, when I press the start button, everything will kind of be paused, and then all of a sudden, about 2 or 3 seconds later, you're going to see data points for a graph starting to form on your phone. But they're going to be right down here. 0 position because you haven't pushed your cart yet. After you see those data points forming, then I want you to give your cart a little bit of a push. Got it? Now, when you see that, when you see the data forming like this, and it's constant velocity, so it should be very close to a straight line, right? If it's close to the other end of the track, I want you to press this button again. It'll be a stop button now. When it's going, it'll be a stop button. You'll see what I mean by that. Red button and the stop. If you have a good section of straight line, you're good to go. You've collected your data. If you don't have a good section of straight line, then you need to repeat that trial. You need to do it again so that you do get a good section of straight line. Now, it doesn't have to be perfect straight line. You might see something that looks like this. This is before I collected the data, and then we have our data, and then we have this. This is before I press start, or sorry, before I push the cart. This would represent after it hit somebody's foot, right? After it was stopped. We only want this data here. I'll show you how to delete all of that other data later on. Okay, that's a kind of deal with it after the fact kind of thing. Okay? Now, one more thing before we set you free to actually collect your data. We need to do something with this. Like, we need to get this somewhere so that we can do an analysis with it. We're not going to do our analysis on our phone or on this app. We're going to do our analysis within Google Classroom and specifically within Google Sheets on our Google Classroom. So we need to get it there. Here's how we're going to get it there. I want you to press the share button. The share button. The share button is right up here. You're going to see a bunch of options, including Google Drive. That is, if you have Google Drive installed on your phone and if you're logged into it, you should see Google Drive as an option. If you don't have that installed and you're not logged into it, please do that. Click Google Drive, and then you're going to save that data to your Google Drive. Does that make sense? Save it in a place where you'll be able to find it. Maybe create a new folder, physics data. You know what I usually do when I do something like this, actually? I go 1 space physics data. You know why I do that? 1 space physics data or a space physics data, because it puts it at the top of my folders. Easier to find it there, right? You do whatever you want. Just put it in a place where you're going to be able to find it. You'll see how you can put it in that place, create the folder or whatever. Once it's saved, then it's time to do the analysis. And that's going to be for another time. We're going to collect our data. We're going to export our data to our Google Drive. And then I will show you how to do the analysis after we've done all that.